If you follow the news from Delhi, you know this sight all too well. That thick, gray winter smog. It's become a depressingly familiar part of the year. And every single time, the same debate kicks off about what's causing it. But what if the story we're all used to hearing is missing the biggest piece of the puzzle? What if the real culprit is hiding, well, not in plain sight, but not in sight at all?
Seriously? What if the single largest contributor to that suffocating haze isn't something you can see coming out of a pipe or a tailpipe, but something that's being invisibly created, right there in the air above the city? That's the question we're going to tackle.
So before we get to the big reveal, we have to talk about the usual suspects. When the air quality numbers start flashing red, the conversation always turns to a very familiar cast of characters.
Yep, we all know them. The exhaust from millions of cars and bikes, all that dust from nonstop construction, the smoke billowing from industrial zones, and of course the big one everyone talks about, stubble burning in neighboring states. Look, these are all absolutely major problems, but they do not tell the whole story, not even close. And that brings us to the real heart of this explainer, the invisible polluter that is actually dominating Delhi's air. And to really get it, we need a super quick lesson in atmospheric chemistry. Okay, so this is the key. You've got two types of pollutants. Primary pollutants are the ones we think of, right? Soot, dust, smoke, stuff that's shot directly out of a source. But secondary pollutants, they are a completely different beast. They aren't emitted from anything, they are created up in the air when different gases react with each other. It's a chemical transformation happening literally right above our heads.
And check this out, this is what's so wild. A huge meta-analysis by the Commission for Air Quality Management, or CAQM, crunched the numbers from a ton of different studies. And the result? Secondary particulate matter is the single biggest chunk of Delhi's winter PM2.5 pollution, a whopping 27%. That's more than vehicles, and it's more than biomass burning. The biggest source of pollution is invisible.
And this isn't just some winter-only thing. An analysis by the Center for Research on Energy and Clean Air, or CREA, found that over the course of an entire year, these secondary pollutants make up about a third of Delhi's total PM2.5 problem. This is a massive, year-round issue. So if these particles are being cooked up in the atmosphere, what's the recipe? Let's break down the chemistry of how the most common secondary pollutant gets made. It's basically a three-step process, and it's pretty straightforward. Step 1, you start with the emission of these precursor gases, things like sulfur dioxide and ammonia. Then, step 2 is oxidation. Once it's up in the air, that sulfur dioxide changes chemically to become sulfate. And finally, step 3, formation. That sulfate finds the ammonia gas, reacts with it, and bingo, you get tiny solid particles of ammonium sulfate. That is a huge part of the PM2.5 haze we all breathe. This diagram really helps visualize this whole factory-in-the-sky concept. I know, it looks a bit complicated, but the core idea is simple. You see the primary pollutants, like SO2, coming from sources on the ground, factories, cars. Then, as they float up, chemical reactions, often supercharged by sunlight, transform them into the secondary pollutants that create that thick smog. It's a full-blown manufacturing process in the atmosphere. So where do the key ingredients for this toxic recipe come from? Well, as you can see here, the sulfur dioxide is mostly an industrial byproduct. Think coal-fired power plants. But the ammonia? Get this, it comes mainly from agriculture. We're talking fertilizers and livestock waste. So you have this really weird and really problematic mix, industrial emissions and agricultural emissions meeting up in the sky to create city smog. And just to give you a sense of the scale of this problem, think about this for a second. India is the #1 emitter of sulfur dioxide in the entire world. That means the main ingredient for this chemical recipe is just incredibly abundant in the air over the subcontinent. But wait, it gets even more complicated. The reason Delhi's winters get so incredibly bad isn't just because these chemicals exist. It's because the winter weather itself creates this vicious feedback loop that just makes everything 1,000 times worse. So, the key idea here is something called aerosol liquid water. It sounds technical, but it's simple. When it gets humid, all those tiny aerosol particles in the air start absorbing water. And this tiny microscopic film of water on each particle acts like its own little chemical lab, dramatically speeding up the reactions that create secondary pollutants. And here's where that vicious cycle kicks in. It turns out Delhi has the highest levels of this aerosol liquid water ever recorded, anywhere. This intense humidity basically acts like a catalyst, hitting fast forward on those chemical reactions, making even more pollution. But it gets worse. This thick, soupy, hazy layer also acts like a lid on the city. It traps everything, preventing the day's pollution from rising and blowing away, especially on those cold winter mornings. So in short, more pollution creates the perfect conditions for making even more pollution. This diagram puts it all together, really. You can see the pollutants coming up from the ground. Then, as the humidity goes up, those particles soak up more water. That's the aerosol water you see. This watery shell then boosts the chemical reactions, creating more and more particles and leading to that dense haze that just traps everything underneath. It is a perfect, self-reinforcing cycle. So, if these pollutants are being formed in the air and are shaped by huge factors like agriculture and power plants hundreds of miles away, what does that mean for actually solving the problem? Well, it means we have to think bigger. A lot bigger. You see, unlike a chunk of dust that might fall out of the air relatively quickly, these tiny secondary particles can stay floating in the atmosphere for days. They can travel hundreds, sometimes thousands of kilometers. This means that the gases being pumped out of coal plants in states like Chhattisgarh and Odisha are directly contributing to the chemical smog that's choking Delhi. And that really brings us to the ultimate takeaway here. This quote from the research just sums it up perfectly. Delhi's pollution crisis isn't just a local problem about what's happening inside the city's borders. It's a vast regional problem that's deeply rooted in this complex atmospheric chemistry. And that leaves us with one final really big thought. If the largest slice of the pollution pie isn't even emitted directly, if it's manufactured in the atmosphere using ingredients from hundreds of kilometers away, can we ever really solve this just by focusing on the sources inside one city? It really suggests that the solution can't just be local. It has to be regional, it has to be coordinated, and it has to focus on that invisible chemistry happening right over our heads.